All right, another way that we can solve quadratic equations, remember quadratic means that we have x squared as the largest power of x, is using square roots. So here's an example. We'll talk about how to do this, but if you have x squared equals 36, that means you're trying to figure out what number multiplied by itself would equal 36. So it's kind of given away. We're going to use square roots today to solve something like this. We'll talk about how your answer can actually be positive 6 or negative 6. That's what this little plus minus symbol represents. All right, so we're going to solve quadratic equations using square roots today. So here's just some examples to get you thinking about this. How many solutions are there, but also what are the solutions? So in number one, if x squared equals 25, I want you to think about what possible numbers, so what number squared can equal 25? What number times itself equals 25? Well, I'd be willing to bet most of you said 5 in your head. You know 5 times 5 is 25, and you would be right that x can equal 5. But there's also another solution, another number that when you square it or multiply it by itself, it also equals 25. And I kind of gave it away on the title screen that it could also be a negative number as well. Think about it. A negative number squared, well, that means a negative number times itself, another negative number, and that will equal a positive 25. So in this case, x can equal either 5 or negative 5, which we can write with a little plus or minus symbol, a positive or negative symbol in front of the 5. Now for the second example, it says x squared equals 0. So what number multiplied by itself equals 0? Well, can't really multiply anything by itself and equal 0 other than 0. That is the only solution to something like that. What about our last example, number 3? What number multiplied by itself equals negative 9? Oh, now wait a second. How do we do that? A number times itself that equals negative 9? Well, it can't be, if you think it's 3, 3 times 3 doesn't equal negative 9. It's got to be negative 3 then, right? The problem with that is negative 3 times negative 3 equals positive 9, not negative 9. So what number squared equals negative 9? I guess there isn't one, at least not a real number. We did learn about imaginary numbers at a previous unit and lesson this year. And in fact, there are solutions to this. They just happen to be imaginary. But for right now, I'm just going to write no real solutions. Just like we did when we solved by graphing, where our parabola never crossed the x-axis. We could say no real solutions. That's going to happen here too. All right, so to kind of understand what we're doing with solve using square roots, I want you to think about these 4 equations and how you would solve these. Not just what is the answer, but how would you solve? How would you undo what's in the equation? So starting with our first example, x plus 4 equals 11. If I wanted to solve this equation, what would I do to get rid of the positive 4, the plus 4? Well, hopefully you selected subtract 4 on each side, because that will give us our solution. Now we subtracted 4 because that will always undo the addition of 4. Something plus 4 minus 4 is just going to be that thing, in this case, x. How about number 2? X minus 9 equals 5. What will undo the minus 9 in that equation? Well, if you said add 9. The opposite of subtracting 9 is adding 9. And that's going to help us solve to get x equals 14. 14 minus 9 equaled 5. 14 is the solution. So the inverse, or the opposite of adding, is subtracting, and the inverse of subtracting is adding. Let's look at number 3. Negative 5m equals negative 20. How do I undo multiplication? We divide. If I want to undo the multiplication of -5, I divide by -5. Anything divided by itself is 1, and 1 times m is just m. So we see that 4 is the solution. If you were to check our solution, -5 times 4 does equal -20. So the opposite or inverse of multiplying is dividing. And I don't have an example of undoing division, but you would use multiplication. I think you guys kind of remember that from earlier this year. However, in number 4, we have a new operation. So c to the second power equals 25. How do you think we are going to undo squaring a number? What is the inverse of squaring? Hopefully, you said the inverse of squaring is square rooting, and you'd be right. So when you square root something squared, the exponent is going to cancel out with the square root symbol, leaving you with just whatever you had inside, whatever's left over. In this case, just the c. Now on the other side, we have the square root of 25, but we have to include the positive negative symbol with the square root of 25. And in this case, we can actually simplify the square root of 25. Since 25 is a perfect square, it just ends up being 5 and -5. So when we write our solution like this, it means two things. It means that c can equal +5. It also means that c can equal -5. Okay, it's just another way of writing the two solutions written as one. Okay, and this is the preferred way to write your answer, using the positive negative symbol. So here are some steps. I'm going to have you write this down. Pause it when you're ready, or pause and continue when you're ready. How do I solve using square roots? First thing you want to do is get the squared part by itself. We'll talk about what that looks like. Then we square root both sides. Don't forget that plus minus symbol. That's such a big important thing. That's how we get our two solutions. We have to have the positive negative symbol whenever you take the square root of both sides, because it's going to be two ways that we can do that. Then the third step, we simplify, including any radicals. If they're not perfect squares, they should be something that you can simplify. And then number 4, finish solving for each x value, because remember, there's going to be two solutions. And then finally, it's a good idea to check your answer by plugging it back into the original equation. So let's look at our first example. X squared minus 81 equals 0. Let's start with identifying what is being squared or raised to the second power. So it's just this x that's being raised to the second power. So when I solve something like this, I want to get that highlighted piece by itself. So I am going to add 81 on both sides because that is the inverse of subtracting 81. That's what's going to get this to 0 out. That leaves me with x squared equals 81, since 0 plus 81 is 81. Now I have to get rid of the exponent. So I square root both sides, and I also remember the plus or minus symbol when I do that. That's going to give me x equals positive and negative the square root of 81. Well, let's see, what number times itself equals 81? That's 9 times 9 is 81. So x can equal 9, and x can also equal -9. Those are the two solutions represented by that positive negative symbol. So let's check that. Let's see if that actually works in our equation. X squared minus 81 equals 0. Let's think about this. If x equals 9, does 9 squared minus 81 equal 0? Well, 9 squared is 81, and 81 minus 81 certainly would equal 0. So that solution checks. Now, what if x is -9? Well, let's see. -9 squared, that means -9 times -9. That's still 81. And 81 minus 81 is 0. That also checks. So we got whatever was being squared by itself first, so that we could square root both sides, and don't forget the plus minus symbol. And then we have our solution simplified and checked. Here's number 2. Again, start with what is actually being squared. It's not the 3x that's being squared. It's only the x that's being squared. I have to do some work at the beginning to try to get the x squared by itself. So let's see. I have to get rid of the 3. I have to get rid of the 75. Let's start there. I always work backwards. So I'm undoing the additions or subtractions. So I still have 3x squared that I bring down. That zeroes out. 0 plus 75 is 75. So far, so good. Next, I want to undo multiplication. So I'm going to divide by 3 on both sides to get rid of the 3. And that's going to leave me with x squared equals 25, since 75 divided by 3 is 25. So now I've got the part that's squared by itself. It's time to square root both sides and remember the plus minus symbol. Well, the square root of x squared is just x. And we have plus or minus, positive or negative. The square root of 25. So what number times itself is 25? Well, that's going to be 5. That's a perfect square. So we get x equals positive or negative 5, which means that x can equal 5 or x can equal negative 5. Let's quickly check our solutions. So go back to our original equation. If x equals positive 5, it would look like this. 3 times 5 squared minus 75 equals 0. I have to check that. Well, I don't do 3 times 5. I do 5 squared first because exponents comes before multiplying. So think of it like that. 5 squared is 25, and 3 times 25 is 75, and 75 minus 75 does equal 0. So x equals 5 is a solution. What about negative 5? Follow that same order. Do the negative 5 squared first. Well, I know that negative 5 squared means negative 5 times negative 5, which is positive 25. 25 times 3 is 75, and 75 minus 75 is 0. So negative 5 is also a solution. Our third example, a little bit different this time. Now we have some parentheses. So when we think about what's being squared or raised to the second power, it's that whole thing. It's whatever's grouped together inside the parentheses that's being raised to the second power. So that already is by itself. It's isolated. So we are ready to basically just square up both sides right away. We want to get rid of that exponent. So we undo it. We use the inverse operation. That's going to leave us with just the x minus 9, because remember the square root and the exponent are going to cancel out. And on the other side, don't forget the plus or minus symbol. I couldn't really fit it in there. But then the square root of 25 is just 5. I think we saw that one already. 5 times 5 is 25. Let's go ahead and change that. All right, so how do we finish solving something like this? So what we do is we basically just draw your line, get x by itself. So add 9 on both sides, add 9 on both sides. X is going to equal positive and negative 5 plus 9. Now, we have to think about what does that actually mean? Well, if we use the positive 5, x equals positive 5 plus 9, which is 14. That's one solution. If we use the negative instead, x would equal negative 5 plus 9, in which case it's 4. So now our solutions at the final answer, the very end, aren't like plus or minus something. It's actually two completely different numbers. I should say numbers that are not their opposites. We get 4 and 14 as the answers. Let's check that. Let's see how that works though. If x equals 14, think about this being 14 instead. In the parentheses, 14 minus 9 is 5, and 5 raised to the second power is 25. That one checks. What about if x equals 4? What if that's just 4? 4 minus 9, well, that would be negative 5 in the parentheses, and negative 5 squared does equal 25. That one also checks. So 14 and 4 are the values for x that would make our quadratic equations true. So be very careful when you have that parentheses that's being squared. We have to treat it a little bit different at the end there. Let's take a look at one more. Here we have 3 times x plus 5 in parentheses squared minus 18 equals 9. So if we go back to what is being squared, what's actually being raised to the second power? Is the 3 being raised to the second power? Nope. Is the 5 being raised to the second power? Not really, not by itself. It's because that second power is part of the, or it's right after the parentheses, it's just the parentheses part that was grouped together that's being raised to the second power. It's like x plus 5 times x plus 5. So on this one, we are going to have to start by trying to get that by itself. Let's see, how do we do that? We have to get rid of the 3, but we also have to get rid of the 18. Let's undo the minus 18 first. That's what SADMAP would tell us to do. So I have 3 times x plus 5 squared equals 27. So how do I get rid of that 3? Well, remember, a number directly in front of parentheses has an implied multiplication there. So if I want to undo multiplication, I divide. So 3 divided by 3 is 1. Leaves me with x plus 5 squared equals 27 divided by 3, or 9. So now I have the part that's squared by itself. I can't subtract 5 here because that plus 5 is in the parentheses. I have to undo what's outside of the parentheses before I can take care of that plus 5. So next is when I want to square root to undo the exponent. Square root both sides, but remember the plus or minus. Need to have that in there. When we do, we'll be left with, let's see, that cancels there. That's x plus 5 equals positive and negative, the square root of 9. Let's see, 3 times 3 is 9, so that's just going to be 3. Keep solving. Subtract 5 on both sides. X equals positive and negative 3, subtract 5. So here's where we have to try to figure out both solutions. I think I'm going to work down this way. So x equals, let's start with positive 3 minus 5. And over here, let's do the other one. Negative 3 minus 5. Okay, so I'm going to point out the difference there. Positive and negative 3. Positive 3 on one equation, negative 3 on the other equation. And that'll help us calculate each value for x. So 3 minus 5 is negative 2. Negative 2 is one solution. Negative 3 minus 5, though, is negative 8. So negative 8 is our other solution. And if we were to actually go back and plug that into the original equation, we'd be able to check that those are our solutions. And it does work out. Those are the actual solutions. So solving quadratic equations, we're going to get 2 answers. Try to get that exponent by itself. Try to get whatever's being squared by itself using your inverse operations first. Then square root both sides like we did right there. Remember the plus minus symbol. Don't forget about that. That's very important. And then when you're solving what's left over, keep in mind we have to split that into 2 separate equations. One where we take the positive value, one where we take the negative value, and finish solving for x in both cases.